Hello guys, today we're going to be going over laws of exponents, and this is IB Analysis and Approaches SL, topic 1, and we're going to be going over the key points and some things you need to remember during an exam. So first of all, this right here is one of the basic log laws that you'll have to remember, right? The way I like to think of it is like this. So a to the power of m is just a times a times a all the way m times, right? So if this was a times a times a, that'll be a to the power of 3. But if it was a times a times a times all the way till it's m times m sets of a, then you get a to the power of m, right? And then you're multiplying that by a times a times a for n number of times. So overall, you would be multiplying a by m set of times and also n set of times. So it'll be a multiplied by itself m plus n set of times. And multiplied by itself, we just know what that is. It is a to the power of m plus n. Alright. Next rule, we have a to the power of m over a to the power of n equals a to the power of m minus n. Take a moment to pause the video and think about how you would approach this problem. So we know that the way I like to think of it is, say we have a times a times a all the way m number of times, and you divided that by a times a times a n number of times, right? So we'll actually be able to cancel some of these out, right? Depending on how many a's, whether there are more a's on top or a's on the bottom, you will get a different value. But essentially, you're cutting out this many a's from the top, right? This number of a's. So n number of a's you're getting rid of from the top. So that'll actually be in total a to the power of m minus n. Next rule we have is a to the power of m to the power of n is equal to a to the power of mn. Now this one's really easy. You just have to think of it like this: a to the power of m times a to the power of m times a to the power of m n number of times, and that'll be a to the power of m plus am plus m plus m n number of times, right? So that'll be a to the power of mn. Alright, next rule we have is a to the power of negative n is equal to 1 on a to the power of n, right? So if we look back to this rule, we can rewrite a to the power of negative n as a to the power of n to the power of negative 1. Now, you probably learned before that anything to the power of negative 1 is just something on itself. It's just that same thing on itself. Like if you have b to the negative 1, that's 1 on b. Or it's reciprocal, right? So if you have 2/3 to the power of negative 1, you get 3 on 2. It's like that. We just flip it around. So a to the power of n to the power of negative 1 is equal to 1 on a to the power of n. Simple. Now, next rule we have is ab to the power of n, oops, give me a second, ab to the power of n is equal to a to the power of n, b to the power of n. Now, remember multiplication, it doesn't matter if we do this or we do this, right? Because in the end we multiply and get the same thing. It doesn't matter the order we do. So this is the same as a times a times a n number of times, right? And then same thing multiplied by, when we don't have anything in the middle between two pronumerals, it's multiplication. B times b times b, that n number of times, right? So in the end we'll get a to the power of n, b to the n, right? That's what this is. Now when you look at this, you have a to the power of ab times ab times ab, n number of times, right? And we can rewrite that as just a times a times a times a n number of times multiplied by b times b times b n number of times as well, which will give us the same answer as up here. So we get back at that, right? Let me just clear out some room here. It's getting a bit messy. And Next rule we have is going to be the fraction rule. So it's a on b to the power of n equals a to the power of n b to the power of n, right? So where this comes from is essentially when you have a to the power of a over b to the power of n, that's just a to the a over b times a over b times a over b, just n number of times. And remember, in multiplication of fractions, you just have to multiply the numerators together and you have to multiply the denominators together. So what you're essentially getting is a times a times a times a, n number of times over b times b times b times b, n number of times as well, which is just a to the power of n, b to the power of n. Yeah. Now the last rule here is, I think it's going to be probably the one where most people get confused, but yeah, it won't be that bad. But it's any number a to the power of 1 on n, right, is equal to the nth root of a, right? This takes a bit more time for me to explain, so I will be doing this in a different video if you guys want, but the short answer is just remember it. Alright, these are all key points you're supposed to remember. Base b of a. As in, what power do I need to raise b to get to a? As in, this number, right, is what this is the power that I have to raise b to get to a. That's how you should interpret logarithms. Now, I'll give you a few problems you want to practice, and maybe you want to pause the video, but yeah, here they are. Log base 2 of 8. Assuming how to go, it's going to be 3 because we know that 2 to the power of 3 is equal to 8. Right? Log base 3 of 27. Again, that's going to be 3 because 3 to the power of 3 is 27. Yeah? Now, log base 3 of 1/9. What do you think that's going to be? It's going to be negative 2 because 3 to the power of negative 2, that's just 1 on 3 to the power 2. If you recall from earlier in the video where we learned the rule where a to the power of negative n is equal to 1 on a to the power of n. So, yeah. Hope you guys had fun watching this video. Make sure you like and subscribe. As you know, I am just starting off this YouTube channel to help everyone out there who's trying to learn any subject. And if you guys have anything that you want me to teach you, just type it in the comments and I'll be happy to teach you. Alright, thank you.